In this lesson, we're going to learn about quadratic functions in vertex form. Vertex form gives us a lot of information about the key attributes, and we're going to work on finding those without even seeing the graph. So first, vertex form is the same thing as our transformation equation for quadratics. So let's remember the transformation equation is y equals plus or minus a, and then in parentheses we're going to have x minus h, and that's going to be squared, and then plus k. And now all of these values tell us something different about the function. So the plus or minus here, okay, if it's positive, my graph opens up, and if I'm negative, my graph opens down, right? So we're working with parabolas, with quadratics. So if it's positive, we're going to be opening up like this, and if it's negative, we're going to open down like that. Separately, A tells us if it's a vertical stretch or a vertical compression. So a stretch is going to make this parabola a lot skinnier, and if A is bigger than 1, we have a vertical stretch, okay, which makes the parabola skinny. Oppositely, if A is less than 1, we have a vertical compression, which makes the graph wider. Now this value inside our parentheses, h is going to tell us how far left or right we're moving. And what we're talking about moving here is the vertex. So remember that h also does the opposite of whatever the sign is. So if we have a positive h, we're going to move left since we're doing the opposite. And if we have a negative h, we're going to move right. Okay, and again, this is moving the vertex point. And the last thing I have is this k. K tells us how far up or down we're moving, and it stays true to whatever the sign is. So if we have a plus k, we're going to move up. And a negative k, we're going to move down. And again, this is for our vertex we're talking about moving. So this is our transformation equation, which is the exact same as our vertex form, okay? And it's called vertex form because with our h and k values, it's very easy to identify where the vertex is. So once we have that vertex, we can find all the other key attributes that we're talking about. So finding our key features, right? Our vertex, we're going to say, is just at the point h, k, because h tells us to move left or right, and k tells us to move up or down the vertex. And so we're going to use that and find our vertex just by looking at the equation. Then my axis of symmetry, remember it goes right through the vertex point, and it makes a mirror image of the graph. And it's going right through the x value, so it's going to be x equals whatever our h value is from our formula. Maximum or minimum, we haven't really talked about this yet. Maximum or minimum is just the highest or the lowest y value that we have. So it's just going to be k, and we're going to tell if it's a maximum or minimum. So if it's a max, we're going to be opening down because then the graph would have a highest value. And it's a minimum if the graph opens up. Okay, and remember that sign at the very beginning will tell us if we're opening up or down. Then the y-intercept is the only thing that we're going to have to do a little math here for. Y-intercept, we're just going to set x equal to 0 and solve. Okay, so our y-intercepts fall on the y-axis, so it's wherever our x is equal to 0. So we just have to set x equal to 0 in our equation, and then we can easily find our y-intercept. So let's try this example here. We got f of x is equal to negative 2 times x minus 3 squared minus 6. We can find the vertex. Remember, my h is inside and my k is here. So my vertex point Remember, I'm always going to take the opposite sign of h. So since this is a negative 3, I'm going to have my h value be a positive 3. And then my k value, I'm going to keep the sign with it. So k is going to be negative 6. So this vertex is going to be at the point 3, negative 6. My axis of symmetry is always x equals h. And we just said h in this case was 3. So my axis of symmetry is x equals 3. Okay. For maximum or minimum, I see that this graph is negative, which means it's going to be opening down. And if we're opening down, we're going to have a maximum, and it's going to maximum at k. So I'm going to say this is a max value of negative 6, because that's my k value from my vertex. And now we can find the y-intercept. All we have to do is say y equals negative 2. And then I'm going to plug 0 in for my x, minus 3 squared minus 6. We can just simplify this now. This isn't going to make any difference. So negative 3 squared would be 9. So I've got negative 2 times 9 minus 6. Negative 2 times 9 would give me negative 18. Minus 6 would give me negative 24. So my y-intercept is 0, negative 24. And so these are our features. And we're missing 2 here. We're missing domain and range. So we're going to talk about that now, finding domain and range from a quadratic equation. Domain is really simple. Remember when we were working with quadratics, they make these U shapes, okay? And so this arrow means that we're going this way and this way forever. So domain is actually all real numbers. For every quadratic function we have, it's always going to be all real numbers for domain. Now if my parabola opens upward, okay, so if it's opening upward like this, I see that I'm going to infinity forever. And my lowest point is right here at my vertex, okay? And if we're thinking about our vertex point, we want it to be y, so I'm looking for k. So in inequality notation, it's going to be y and k. And if it's opening upwards, all of these y values are going to be greater than and equal to, because we're always going to be touching at our vertex point. In interval notation, it's going to be from k to infinity. If the parabola is opening downwards, again, we're going to have our vertex at our highest point now. And once again, that's going to be k. But now I see that all of my y values are going down. So we're going to flip everything. So my inequality notation is going to be y is less than or equal to my k value. And then this one's going to start by going down to negative infinity and finishing up at k for my interval notation. So finding the domain and range of the example that we were working with is super easy. What we're going to do is we're just going to, do inequality and interval. So for domain, all real numbers, we can write it as this r with an extra line. And my interval notation says negative infinity to positive infinity. Now, again, this graph is negative, so I'm opening downward, so I'm looking here. So I'm going to say y is less than or equal to, because that's what I'm saying for my downward, since all of the y values are less than my k value vertex. And my k here is this value that's being added out here, which is negative 6. So this would be my inequality notation. And my interval notation would be negative infinity to negative 6 with a bracket like that. So to summarize, how do we find the key features from its equation? The first and most important thing is to find the vertex, because the vertex is going to be able to tell you all of the other values with h and k. We can also find range from the vertex by first just determining if it's opening up or down, and then we've got a couple different formulas that we can just plug our k value into there. So I hope you had as much fun as I did in this lesson, and I'll see you in the next video.